Paragraph from a second edition of a well-respected book on, so I guess you can start the camera if you want.
I did.
This is an early paragraph of a second edition of a well-respected book on biophysics. And it's this is the original text, and I've tried to improve it here. This is a first pass at improving the text. And so, first of all, there's a mistake, and this mistake is a consequence of their not following Orwell's rule to avoid Latin and Greek and various foreign phrases, because their data is plural. And in fact, he's all kinds of qualitative data. Data there is obviously plural, as it is in Latin. And then they say, this data, this is a singular adjective, so this is just stupid. And if we keep the Latin, then we change it to these data, although we could avoid the Latin completely. Anyway, I was teaching out of this book, actually, by mistake, and preparing for class, it nearly drove me mad reading these long sentences, and so I shortened it. Basically, well, I don't know whether we should see what the details are. So this is the goal of this chapter, to sense of the kinds of quantitative data that are being obtained in all fields of biology and the models that must be put forward to greet this data. Greet, my God. Anyway, the goal, so I changed it on the first pass to the goal of this chapter is to learn about the kinds of quantitative data that are being measured in biology and the models that can interpret these data. So then the next sentence here is like with any useful map, we will argue that any good model has to overlook some of the full complexity and detail of a given biological problem in order to generate an abstraction that is simple enough to be easily grasped by the human mind as an aid to developing intuition and insight. So that's a model of a horrible sentence. So I changed it to: a good model overlooks some of the complexity of the biological system in order to be simple enough to be easily understood. But useful model, the next sentence here is, at the same time, it is critical that useful models make meaningful predictions, so they must include at least some of the realistic details of the biological system. So I changed that to, but useful models make predictions, so they must include enough detail to do that. Then the next sentence, I didn't change very much. I just changed it to: the art of model building lies in striking the proper balance between too little detail and too much. Part of our emphasis on model building centers on the role of having a feeling for the numbers, sizes, shapes, times, and energies associated with biological processes. Here we introduce the style of making numerical estimates that will be used throughout the book. So I changed that to: the first step in building a useful model is to learn the sizes, shapes, times, and energies of the biological system. Here we show how to estimate such things. So one could, I think, collapse this down to perhaps even 2 sentences, but I stopped at this point. Does anyone want to suggest a further improvement or a different way of shortening these? The funny thing about writing like this is that when you read it, nothing jumps out of you. It's not, apart from the Latin and another mistake in grammar that I didn't bother to mention. Nothing jumps out at you. It's just long-winded. All right. So let's go to the second example. This one somebody sent in, and So I tried to improve it a little bit. However, I don't know anything about the subject matter, so I didn't really know how to improve it, but, oh, Christ. So let's see. The first sentence is, this small-scale study aims to find patterns and disparities of non-linguists' views on English dialectical differences in the United States. So I changed that to this well, there's a hyphen that you need for small-scale studies. Aims to find patterns and disparities in how non-linguists perceive English dialectical differences in the United States. So I think that's a little bit clearer. The problem with this, one problem with this paragraph is the word study is used too many times, so that it's somewhat confusing. So I kept study for its first use, this study here, and then use the word work for other things. So the text's second sentence is, the study itself is influenced by social psychologist Wallace Lambert's study on matched guys and Nancy Niedzilski and Dennis Preston's studies on folk linguistics. So I changed that somewhat to, the study is influenced by the work of social psychologist Wallace Lambert on matched guys and by the work of Nancy Niedzilski and Dennis Preston on folk linguistics. Part of the reason that I changed it this way, well, I wanted to use work instead of study, but it's also that just reading this, it wasn't clear what that name was. Was the apostrophe associated with both of them? And frankly, I didn't really know how to punctuate it, so I wrote it in a way that I think was clearer anyway. Does anyone know the rule? No? All right, okay. All right, so in the sentence up here, what we have is in Wallace Lambert's 1960s matched guys study, hyphen, a method measuring language attitudes mentioned in Niedzilski and Preston's work. Speech samples were produced by the same person but vary in some domain. Okay, so I changed that, I think, making it clearer and shorter. First of all, you don't want a hyphen. What they meant was a dash. And LaTeX is marvelous in that it has, let me show you on the blackboard. In LaTeX, that's a hyphen. That's the sort of small dash for things like 10 through 20. And that is the dash that occurs here, which is the appropriate dash for this case. So I changed it to, in Wallace Lambert's circa 1965, matched, there's a hyphen that you need there. Matched guys work, then a real dash, a method measuring language attitudes cited by Niedzilski and Preston, another hyphen. Speech samples were produced by the same person but in different ways. And that's a simpler, clearer way of... Is there any way of preventing this from happening? Does anybody know how to...
Accept the terms of the use and log in.
Accept?
Yeah.
But I'm not going to log in. I don't know how to
It
log
doesn't
in.
make you log in to your account.
Okay. So then, let's see what the original was. An example of this variation is a single person speaking with different accents. I changed that to, for example, a single person might speak with different accents. And so I think that's a little cleaner. Oh, well, I need to show you both on this. So up here, well, let's see. All right. Within this study, Lambert presented a bilingual speaker who produced speech samples, one language per sample in both French and English. And so I changed that to, in this work, Lambert presented a bilingual speaker who produced speech samples, one language per sample in French and English. So that, I didn't change it very much. Guys here references characteristics of a given language. So I changed that to guys here refers to the characteristics of a given language. And then I'll have to show you what was written and then what I wrote. Participants were asked to rate the French guys and the English guys as a speaker. Participants were unaware that the samples were produced by the same speaker. Studies following this format have had a considerable split of ratings between status and solidarity. I didn't know what that meant, so I didn't really know how to edit that. Participants were asked to rate the French guys and the English guys. Yeah, I don't think that guys should be capitalized. Participants were unaware that the samples produced by the same speaker. Study following this have had a consistent split of ratings between, and I just put them in lowercase. I don't know what that means, so I couldn't edit it. Does anybody have comments or questions? Yeah.
Can you omit one of the guys there, like friends, and can you?
One of the what?
There, I think French guys and English guys. So can we make like French and English guys of the speaker?
Let me understand what you're saying. Say it again now.
There were, I see like participants were asked to rate the French guys and English guys of the speaker. So instead of that, can we omit one guys and make like French and English guys of the speaker? I see on like.
Where do you? Why don't I give you the?
Okay, sure. I will show you where.
It's just like this. It doesn't get cut out.
Here I see like participants were asked to rate the French and both right. So can I omit one of the guys?
I would think that would be an improvement. Yeah. So let's see. Yeah, I would say we're asked to rate the French and English guises of the speaker. I would think that'd be better. It just didn't occur to me.
I'm just thinking about whether it works or not.
Yeah, well, because what you need to do is you need to understand what the subject, what the content of the passage is before you can really edit it. And I have no idea I've never heard the word guys used in this way. In fact, I've almost never heard the word guys used. I've heard disguise, but not guys.
We're using the rules.
Hmm?
We're using any of the rules from.
Yeah, I've been using all of these rules. And in particular, maybe use a long word. If you can take a word out, take it out. Don't use the passive. Maybe use a foreign word. Now, what I did here was the first pass at the thing. One could go on and on and on. Yeah.
When we use the dash and put statements between them,
I'm sorry.
we using the dash and putting some statements of like one language per sample.
Yeah.
What is the rule when we use dashes?
Well, I think they always come in pairs, and no, actually they don't always come in pairs. It's kind of like, well, dash is used in two ways.
Yeah, actually.
You can say something and then have a dash and something else. Anybody have an example?
It's kind of like when you have a parentheses and you want to like add.
That's right. Well,
something.
that's when you have a pair of dashes. So you could have, for example, here, gotten rid of the two dashes and put a parenthesis there and a parenthesis there. That's the way dashes are being used here. Another way of using a dash is like a colon. You have a sentence saying something, and then you say it in a brief or clever or funny way after a dash. And you just sort of emphasize the thing you've been saying. All right, so we've gotten rid of that one. Now this, I don't know what this is, but since somebody sent it to me, I took a first pass at it, but partly to correct this thing. This is people often say that energy is not conserved in general relativity, and yes it is. And in fact, energy is the field energy or potential energy of gravity is typically negative. And so what happened in the current model of inflation, of the Big Bang, is inflation. Maybe since this is a physics department, I maybe should say a few words about this. So the idea, and this is not really supported, certainly by experiment, but it's consistent with all observations so far. The idea is that there was a fluctuation of one or more scalar fields in possibly a very, very small volume of space. And that fluctuation led to an energy density in that very small region, which could have been smaller than a nucleus, really small. But it could have been bigger, but really small, let's say. A small fluctuation, a big fluctuation in a small space. That meant that the energy density in that small space was huge. Now, general relativity says that if you have, in a certain volume, an energy density that's huge, a potential energy density that's huge, and the rest of the energy density is only moderate, then that region of space will expand. The scale factor will expand. And in fact, it expands exponentially, e to the something times time. And so that tiny region then expanded like crazy and became the known universe. Now you would say, well, what about conservation of energy? Well, as this tiny region expanded and created all the ordinary energy that we see in the universe, correspondingly there was a negative potential energy created in the gravitational field, so the total energy was conserved. So energy is actually conserved in cosmology. What is a little bit subtle is that that general relativity has, the essence of general relativity is that the action is invariant under general coordinate transformations. And under general coordinate transformations, energy doesn't transform simply, it gets all screwed up in general. So what you do when you say that energy is conserved is you decide you're going to have a certain reference frame, a certain set of coordinates, stay with that set of coordinates, and that set of coordinates you quantize the field and you talk about the energy of your system, and then that thing is conserved. Okay, so that was a physics tangent. So I don't know. I just tried to improve this a little bit, and I'm not sure. I didn't really make a detailed effort because I really couldn't understand what the guy was saying. Yeah, I think we better skip this one. So I just fixed the physics. I tried to fix the prose, and but since I didn't really know very much about what he was saying, I don't know. All right, so here's an example of something that somebody sent me, and so this is the original text, and I don't think there's anything particularly wrong with this text, but I tried to improve it. So, I mean, you see, you don't know. It could be that on the previous page, or 5 pages back, or 1 chapter back, EAM was defined. And so, assuming that nothing had been defined, I defined it here. So I said here, Ferron et al. Carried out, oh, well, the one problem is you need a hyphen there. Molecular dynamics simulations relying on embedded atom model interactions. So, in fact, I could have used maybe a different, a third hyphen there. So EAM stands for embedded atom model. And so I changed this second sentence a little bit. It was, they saw long jumps as well as rebound, recrossing jumps in self-diffusion on copper, and claimed that at 500K, 95% of the jumps were correlated. At 100, this decreased that. So I changed it a little bit to, they saw long jumps and rebound, recrossing jumps in self-diffusion on copper, and claimed that at 500K, 95% of the jumps were correlated, whereas while at 100K, only 50% were. So that's a little bit clearer. Let's see, they continued their simulations using the dynamo code and atomic interactions derived from, I think I just left that sentence unchanged. Then up here, a number of correlated jumps, including atomic long events, as well as ballistic transitions, were identified at temperatures ranging from 7% to 12% of the melting point of copper, with the likelihood of correlations increasing with increasing temperature. So I changed that a little bit. They saw correlated jumps, including atomic long events and ballistic transitions, at temperatures ranging from 7 to 55% of the melting point of copper. The likelihood of correlations and the characteristic jump length increase with temperature. So I think that's a little better. Did you have a question?
What you put between the commas there, could you also include a dash?
Where is this?
When you clarify on including atomic long events and ballistic transitions, would it be all right?
I guess, yeah. I think you could get away with dashes, yeah. All of this stuff is really usage, and if everybody starts doing things a certain way, then that becomes the accepted way of doing things. So I don't know whether there's a fixed rule on that. All right, so let's see. Where also observed was a linear increase of the characteristic jump length with temperature. I think I put that into that sentence already. The average distance covered by atoms increased faster than expected for a random walk between nearest neighbor sites. I changed that to the average distance covered by absorbed atoms, parenthesis atoms, increased with time faster than expected for a random walk. I think that part is confusing and badly written. Any questions? All right. Okay, this one is rather abstract mathematical physics. This is the original version, and what did I do to change this? All right, the first sentence is, in this paper we propose a model of the Berzan integral as a literal limit of the Riemann sum that corresponds to a surface integral. So I changed that to, in this paper we propose a model, so I dropped out the future tense, I just said we propose, a model of, I left out a the, this should be the, or Berzan's integral. So I screwed up there. As the Riemann sum of a surface integral. So I think that's clearer and shorter. Then the original had, thus the fact that Berzan integral coincides with the derivative is a simple consequence of divergence theorem. All right, so the author of this has Russian as his native language, so I changed that to thus the fact that, my God, I left out the again. The fact that the Berzan integral is a derivative is due to the divergence theorem, so that's shorter. The fact that Berzan integral doesn't obey the scaling properties expected of order unit is attributed to the fact that the Berzan integral is claimed to give the expected value only if the volume enclosed by the sphere is 1 over d, where d is the dimension of space-time that is sent to infinity, and therefore the rescaled surface no longer gives. All right, that's much too long a sentence. My first pass at doing something with it is the Berzan integral doesn't obey the scaling properties expected of order unit because. The word because is a word that children use a lot in English, and children speaking English use a lot because, and it's a word that's very helpful in professional writing, and I really encourage you to use it. Anyway, so I say, because the volume enclosed by the surface is 1 over d, where d is the dimension of space-time sent to infinity at the end. One could have had a period there, but I put in a semicolon. Therefore, the rescaled surface no longer gives the expected value of the integral. So that's that, and then finally what? Finally, the Berzan integral can return scale of value. All right, this needs work. Due to the richer structure referred to geometric algebra that combines the anti-commuting wedge product with the Clifford product. So I change that to, finally, the Berzan integral will return a scalar value due to the richer structure of a geometric algebra that combines the anti-commuting wedge product with the Clifford product. I think that's better if I haven't changed the meaning. And while the finite part of the integral has wedge product, as always, the product between finite and infinitesimal part is Clifford, which is what ultimately allows for the outcome to be a scalar. Okay, I don't really know what that means, but my guess at changing it was, while the finite part of the integral has a wedge product, as always, the product of the finite and infinitesimal parts is Clifford, which makes the outcome scalar. Well, as I said, I don't know what was being, I don't really understand what's meant, and so I just basically guessed. All right, those are the examples, and that's basically all that I was intending to talk about, but maybe you guys have questions and we could talk about, or suggestions, criticisms.
Okay, so what I meant, what there is basically...
All right, but that's much, you should talk with me about that
Okay.
privately, right?
Okay.
I can send you, I will put this on the class webpage, this PDF on the class webpage tonight, so you can look at it. Did anybody, but did you have a question?
Oh, I was just wanting to understand why you didn't know what I meant and was just trying to explain to you what I meant.
'Cause I'm not smart enough to understand what you meant.
Well, I mean, like, if you take integral f of x dx, f of x is finite part, dx is infinitesimal part. Now,
Oh,
if
all
you
right,
take
okay,
integral
okay.
f of the, yeah.
Okay, that's cute. Yes, now it makes sense. But let's not go into your advanced mathematics in this class. Did somebody else have a question? Yeah.
Not a question, but I looked up the rules for possessive when there's more than one noun.
Oh, okay.
Yeah, and so if each of the nouns owns that one thing,
You can have it on her if you want.
So if there's one object that's owned by two things, then you only put the apostrophe on the last noun that's owning it.
Okay, so the way it was done was correct.
Yeah, and if each person or thing owns that object, like a different kind of that same kind of, I'm trying to figure out how to word it. Like if they had both written a paper on the same subject, but it wasn't the same paper, then there would have been apostrophe on both
Each of
nouns.
them. Okay, thank you.
Yeah.
All right. Okay, anything else? Yeah.
If these are such bad examples and a lot of them can't be understood, how is it that they got published?
Oh. Well.
Because aren't these peer reviewed several times before?
Oh, well, the peer review in okay, it's, first of all, we're talking about articles or books.
Articles, generally.
Well, the peer reviewing of an article of a physics article is mainly the evaluation of the physics. And, in other words, is what was done correct, first? Secondly, is it new? Thirdly, is it important? And so those are the three things that are supposed to be applied. Now, what often is applied is that there's a fourth thing added. Will this increase the impact factor of the journal? And that's regarded as more important than the first three. But the quality of the prose, I think that's never a reason to accept or reject a paper. In a physics journal, and probably a biophysics journal, probably a medical journal. Now, what is true is that if the paper is well written, then the referee might have a higher opinion of the paper. So, in other words, if the writer writes so poorly that the logic and the significance are obscured, then the referee says this is mush. If, on the other hand, the writer writes so well that the logic and the significance and so forth are apparent, then the referee is much more likely to rate the paper more highly. One thing that I noticed, by the way, is that when I mentioned who are the writers that we should imitate, if you remember, I said to you, I can tell you how not to write terribly. I can't really tell you how to write like Shakespeare or really well, or like Tolstoy, or like the best writers in physics. And then I gave you a list of various authors who I think are among the best writers. Turns out many of them are professors at Harvard. So in other words, either the good writing was just an aspect of their general intelligence, or the way they got to Harvard in part was that they knew how to write. And so I'm not sure. I expect that there's a feedback between the two. I once wrote a paper and then got a referee report. And the referee report was written so well that I knew who wrote it. And so I wrote back saying who it was and giving my rebuttal. And the referee turned out to be Sidney Coleman, who was one of the best theorists and best writers of physics at the time. And his reply to me was, first sentence was, exposed. And they accepted the papers. But anyway, I don't know. I think maybe next time I'll find some examples of good writing, and that might be fun to look at. It certainly would be more fun looking at good writing than looking at terrible writing. But as far as books go, yeah, this book that I first gave, where all the sentences had 10 or 20 extra words, that is regarded as the best book on biophysics. And when I was teaching from it, it nearly drove me mad reading the thing. All right, I guess we're out of time. So if you have suggestions as to what to cover in next week or whatever, send me email. I'm thinking of moving the class to a different room, but if you like this room, maybe we should stay.
Yeah, that's right.
Trouble is, this internet is just such a pain.
So if you hit log in, you don't actually have to put it in the code. It's like a guess.
All right.
All right, let me try it.
I'll see you later. I'm still
Let me hit
working
accept.
5
Yeah.
hours while we
Yeah,
collectively
stop.
hallucinate.
Then I hit log in.
I guess use this one.
Now
First
what?
off,
Yeah, you're done. You can
that's
Huh?
And then you can just
Oh, really?
Second,
yeah. And so every time you reconnect to the
Yeah,
gas.
stop.
Oh no.